We now turn our attention to an application of solving rational equations. In other words, we want to now use our skills that we have developed for solving rational equations to solve some realistic problems involving work. Let's start by taking a look at an example. Grandpa Smith needs to fill his backyard swimming pool. If he uses a regular garden hose, it would take him 6 hours to fill his pool. If he uses a certain type of high flow hose, it would take him only 3 hours to fill the pool. If he uses both hoses together, the question is, how long would it take him to fill the pool? This is an example of a typical work problem, where you have one person or object that works at a certain rate, and then a second person or object that works at a certain rate. The question is, how long would it take them if they work together to complete a task? So let's analyze and break down this problem a little farther so that we can develop a strategy for solving work problems. Our first observation is that because the garden hose can fill the pool in 6 hours, then it must fill 1/6 of the pool every hour. Think about it. The garden hose can fill the pool in 6 hours. So in 1 hour, only 1/6 of the pool will be filled using the garden hose. Second, because it takes 3 hours for the high flow hose to fill the pool, it must fill 1/3 of the pool every hour. And again, think about it. It takes 3 hours for the high flow hose to fill the pool. So in 1 hour, 1/3 of the pool is filled by the high flow hose. So let's now make a third observation regarding this work problem. Let's consider what happens when we put the hoses together. In other words, we have both hoses at the same time filling the pool. Well, putting the hoses together has the effect of adding their rates. In other words, think about it. The garden hose, it works at a rate of 1/6. In other words, every hour it fills 1/6 of the pool. And the high flow hose, that works at a rate of 1/3. In other words, every hour 1/3 of the pool is filled. So in 1 hour, 1/6 of the pool is filled by the garden hose, while 1/3 of the pool is being filled by the high flow hose. So if you add these two fractions, that means that 1/2 of the pool is filled every hour when these two hoses work together. For those of us that might not immediately see how 1/6 plus 1/3 equals 1/2, recall that when we add fractions, we need to have a common denominator. You just can't add straight across. And so when we're adding 1/6 plus 1/3, this is in effect the same thing as adding 1/6 plus 2/6, right? Like denominators. That gave us 3/6 or 1/2 of the pool. So pulling all of this information together, this would tell us that if the two hoses were working together to fill the pool, they would be able to fill half of the pool every hour. Does that make sense? They could fill half the pool every hour when they both were turned on, working at their individual rates, right? So working together then, that means that if half the pool gets filled every hour, then the whole pool would get filled in 2 hours. Thus, we've solved our problem. If Grandpa uses both hoses together, it would take him 2 hours to fill the pool. This idea of adding rates to get a total rate is the strategy we need to solve all types of work problems. So let's look at that generalization right now. Let me reiterate what I just stated. That is, instead of just adding the times together to solve the problem, what we did was added the rates of the hoses. Now, to form each rate, we divided the number of tasks completed by the amount of time it took to complete the task. In other words, we have three rates: 1/6 plus 1/3 equaled 1/2. And in each rate, we took on top the number of tasks that needed to be completed. In our case, we had one pool that needed to be filled, and therefore 1 was the numerator for each rate. Now, 1/6 came from the fact that it took 6 hours for the garden hose to complete that one task of filling the pool. 1/3 came from the fact that it took 3 hours for the high flow hose to complete the task. And 1/2, which came from adding 1/6 plus 1/3, told us that when the two hoses were added together and working together, they could fill the pool at a rate of 1/2. In other words, one pool was filled in 2 hours. Looking at this statement right here, this equation, these observations can be generalized to make a formula that we can use to solve any work problem. The work formula is 1 over A plus 1 over B equals 1 over T, where A is the amount of time it takes for a person or thing to complete some task. B is the amount of time it takes for a different person or thing to complete the same task. And T is the amount of time it would take if the two people or things worked together to complete that same task. This here is the generalized work formula that we can use when we're solving our work problems.